All right. Integration by substitution. This is how we will do, or undoing the chain rule is basically what we're going to do today. By the way, there was a chain rule derivative problem on the test. Find the derivative of sine of 3x, I think it was. I don't remember how many got it right or wrong, but that was on there. Let's do a chain rule problem right here. Whoops. Take the derivative of sine of x cubed. Take the derivative of sine of x cubed. So the derivative of sine is, you can go ahead and answer that, cosine. So cosine of x cubed. But then what does the chain rule say? What's the rest of the answer?
It's multiplied by 3.
Multiplied by what?
Wait, no. 3x.
3x squared.
Yeah.
That's the chain rule. And so when we're doing triangles or u's, we said this is u and this was du. Or it was the old pink triangle. Uh-oh, I don't have my pink highlighter, so it can't be a pink triangle today. It'll have to be an orange triangle. Like that. Triangle and triangle prime shows up. That's the chain rule. Hopefully that's old news. So today we're going to be looking at basically this side of the problem and trying to antiderivative something, and we have to be able to recognize that, wait a minute, that was a chain rule situation, and that's why this 3x squared showed up. So here's the only instruction of the day, and then we'll do some examples, a lot of examples. Pick u so that du is part of the integral. That'll make more sense once we do some of these. Probably doesn't make much sense right now. Integral of 2x times x squared minus 1 to the 5th dx. And again, I'm thinking chain rule because I can't integrate the pieces. A few of you tried to do that on some of those where you had to do algebra first. You can't integrate pieces. You got to integrate kind of the whole thing at once. So I'm looking at this, and this is one of those things where the more you do, the more you get used to it, the easier it becomes. But initially, it may be kind of hard. I want to look at this integrand, what's in here, and see if part of it is a derivative of another part of it. So can you look at that now and see, oh, wait a minute, this part of the integral is a derivative of another part of the integral? Do you see anything that looks like that? The 2x, because what's it the derivative of? So if I let u be x squared minus 1, then du dx is 2x. And then this next step is a little bit strange because du dx is not a fraction, but we kind of treat it like a fraction. So we'll move the dx to the other side. And then now this combination of 2x and dx make up du. And we said x squared minus 1 was u. And then that 5 is still there. So now we want to integrate u to the 5th du, which is a lot easier integration than what we started with. So u substitution takes an impossible integral and turns it into something that's a whole lot easier. So how do I integrate u to the fifth? Add 1 to the exponent, put it over the new exponent, plus c. So the actual integration was pretty easy. It was the substitution to get there that was maybe the tricky part. Now this isn't our final answer because our initial problem had x's in it, so we want to put the x stuff back in for u. So in place of u goes x squared minus 1, and then that is our answer. If we wanted to check, we'll check this one. We won't check all the rest of them, but we'll check this one. So let's take the derivative of what we just found and see if we get back to where we started. So something to the sixth, so I'll bring the 6 down, decrease the power by 1, and then chain rule, multiply by 2x, and then sure enough that's where we started, so it checked out. These are kind of puzzle problems. You just got to do a bunch of them until you get the hang of it, and then you start recognizing, oh, if I let u be this, then there's du. But initially, they're kind of tricky. Three x minus 2 to the fourth dx. Let's integrate that. Again, you could do algebra on that one, but I don't really want to force that out and have a mess on my hands. So instead, I want to let u be something so that du sort of shows up. This one's a little bit harder because it's not as obvious, I don't think, what u should be. Because there's not something that there's not a du really that's in there. If you had to guess, any guesses on what you think u should be? It's not going to be the exponent, it's going to be this stuff. And then what would the derivative of 3x minus 2 be? 3. So du is 3 dx. Okay, well I don't have 3 dx. But what I can do, only with numbers, don't do this with variables, but with numbers, I can say, well, I would really like to have a 3 dx in there, so maybe I'll just put a 3 dx in there. Now, you're right to make that face, because like that's not legal. But if I put a 3 in there, I could put something else somewhere else to basically counteract that 3. So I could put something out front. What would counteract multiplying by 3? A third. So I haven't changed anything. I've just sort of rearranged how it looks to force part of this to be du. You can do that with numbers. You can't do that with x's. You can't say, oh, let me put an x in here and then a 1 over x out front. Only numbers can you do that game with. Well, now it's an easy problem. That's the point of u substitution. Once you figure out the puzzle, you end up with an easy problem to work. So u to the fifth over 5 is still a 1/3 out front. Again, we introduced the u, so we don't really want u as part of the answer. We want our answer in terms of x. So 1/15, 3x minus 2 to the fifth, plus c. wish there was some tried and true method that would like work all the time, but this is not a plug and play kind of thing. This is a get experience doing it so that you recognize what makes a good pick for you so that DU shows up. And that's why today is just a bunch of examples. Try to get us closer to that point where we feel comfortable identifying U so that DU shows up. Integral of the square root of 5x plus 4 dx. Well, this is only example number 3. Any guesses what U should be? I mean, there's only so many options on this one. 5x plus 4. Let's let 5x plus 4 be U. So what would du be? And I'm kind of... Yeah, you can say du dx equals 5, or you can kind of go ahead and move the dx over on the kind of all-in-one. So I don't have 5 dx, but I can force the 5 dx in there because it's just a number. So 5 and 1/5. And so now I have du in there. So the integral of, I need to rewrite this. What's the square root? How could I rewrite square root? U to the 1/2 du, and don't forget the 1/5 out front. Okay, well now it's easy integration, or hopefully easy integration. Up the power by 1. And divide by 3/2, but I don't want to divide by 3/2. I'd rather multiply by 2/3. Don't forget the 1/5 is still out front. And if you were worried about fraction multiplying, you could leave that alone, right? Like that's a safe stop. So if you were really concerned about how to multiply fractions, you could leave that as is. I'm going to go ahead and take that adventurous step of multiplying. And then u is 5x plus 4 to the 3/2, and don't forget the plus c at the end. Again, if you pick u correctly, things work out pretty well. Integral 2x squared square root 1 minus 4x cubed dx. Thoughts on what u should be? Yeah, you guys. Because if u is 1 minus 4x cubed, then du is negative 12x squared, which isn't exactly what we have, but we can sort of force that into the problem.
How is it negative 12x squared? I'm confused.
Because the derivative of 1 goes away, and then the derivative of negative 4x cubed, bring the 3 down.
So it's just taking the derivative?
Correct.
Oh, okay. Got it.
Yep, u and du, so it's derivative. This is triangle, this is triangle prime, if we're thinking back to the triangles, or the orange triangles. So I don't exactly have negative 12x squared, I have 2x squared, so I'm only off by a number, so I can fix that. What should I multiply by to make this work? Negative 6 on the inside, and then negative 1/6 on the outside. So this combined with this is du. So negative 1/6 out front, integral of u to the 1/2 du. So up the power by 1, divide by 3/2. And I guess just to emphasize the safe stop nature, and maybe I don't want to risk canceling the wrong things or multiplying wrong, I can just leave those fractions together. And then I need to put u back in 1 minus 4x cubed to the 3/2 plus c. Again, it's just practice, practice, practice until you start recognizing what to pick so that the rest of the thing makes sense. Here's a little bit different way to ask the question. Solve for y if dy dx equals 7x over cube root of 2x squared minus 1. This adds a little bit of a step at the beginning. Let's move the dx to the other side. Again, dy dx is not a fraction, but we treat it like a fraction. That's not really a satisfactory answer, I guess, but and then we can, I don't know that we've done this before, we can integrate both sides. That's like, just like way back in Algebra 1 or even 6th, 7th, 8th grade, like you learned, oh, you can add 5 to both sides and it keeps the equation the same. And a little later you said, well, you could actually multiply both sides by 3 and it stays the same. And then you got more advanced and said, well, you could square both sides or square root both sides. So it's that same idea. Obviously it's a little more complicated, but we're just going to take the integral of both sides. Now, the integral of dy can also be a 1 there if that helps. That would just be y. So we like that side. That would be y. And I should be careful. Well, I'll do it this time and then we won't ever do it again. Y plus c. And we don't ever have to do it again because there's going to be a plus c on the other side. So you don't need 2 plus c's. So usually we say y equals and just put the plus c on the other side. But if we were just looking at this, the integral of 1 dy is y plus c. Now, the other side is the fun side there. Ideas for what u should be so that something like du shows up? What's that? Let's let u be 2x squared minus 1. Because then du is 4x. Like, okay, that I can work with that. It's not perfect, but it's not awful. 7. Well, if you don't like messing with the 7 or trying to figure out what do I multiply by to get the 4, then just take the 7. So you know what? Let's just take the 7 out front and be done with him. That's completely legal because it's just a number. You can slide a number in and out. So I'm going to move the 7 out front because I don't want a 7 there. I want a 4 there. I can put a 4 there, but what price do I pay for putting a 4 there? Yeah, I need a 4 in the bottom out front. Okay, so let's see what we're at here. So out front there's 7/4. Integral of, well, this 4x dx is du. And then 1 over cube root of u. Except I don't like integrating roots. I like integrating powers. So what is the cube root of u? 1 over the cube root of u as a power. I think that was on the test, wasn't it? Something really close to that. It might have been 1/4. So yes, 1/3 would be the root, but why is it in the bottom? So negative. I hope you're thinking, yes, I got that one right on the test. Maybe you're thinking, dang it, I missed that one on the test. Let's see, up the power by 1. I was ready to throw something at some people. Negative 1/3 plus 1. Fraction experts. 2/3. And then divide by 2/3. Or multiply by 3/2. Plus c. So these c's are different c's. It doesn't really matter what they are because it could be anything. Although don't like subtract c from both sides and then say it goes away. Just put the c on one side. And I don't want to, it's too early to worry about multiplying and reducing. I got other things to worry about, so I'll just leave the fractions alone. U is 2x squared minus 1 to the 2/3 plus c. Oh, nothing reduced anyway on that fraction. Another solve for y given dy dx. Dy dx equals x plus 2 over square root x squared plus 4x minus 5. So move the dx over. Again, it's not a fraction, but we kind of treat it like one. Integrate both sides. Left-hand side's easy. Just get y. I guess technically there's a plus c, but we know we're just going to hold that to the end and stick the plus c on the x side of things. All right, thoughts for what u should be on this one? The quadratic. Okay, let's try that. Keep waiting for you guys to guess the wrong answer so that we can pursue a wrong answer, because that happens in u substitution. You guess something, you start working with it, and it just won't work. Start over, pick a different u and see if something works. Let's see, du is 2x plus 4. Is that good news or bad news? Or medium news?
Well, couldn't you just multiply the top by 2?
Yeah, like it's not perfect, but it's not a difficult fix. Because if I multiply the top by 2, then I get 2x plus 4, and I'm good. I got to put a 1/2 out front to account for that.
Why? What's the 1/2 again?
Because you wanted to multiply by 2,
Right.
which I like, but you can't just go multiplying equations by 2. That's not allowed. So if you multiply by 2 and multiply by 1/2, you haven't changed anything.
Oh, because I was gonna say, well, why don't you just put the 2 at the y, but that's the same, because then you just have to simplify it.
You absolutely could do that. Since it's an
Yeah.
equation, you could multiply this side by 2 and put a 2 on the y.
But then you just divide it by, like, you multiply by 1/2 anyway.
Yeah, and eventually you divide by 2.
Yeah.
So that's absolutely an okay thing to do. Yes. Although be careful, because that would only work when we have equations. The first 4 weren't equations, so you had to do the 2 and the 1/2.
Yeah,
So-
no, it makes sense. It makes sense.
So 1/2 integral of, okay, now all of that stuff is du. 1 over the square root of u. Again with the square roots. We don't like roots, we want powers. increase the power by 1, divide by 1/2, divide by the new power, plus c. That's kind of convenient. The 2 and the 1/2 cancel. So x squared plus 4x minus 5 to the 1/2 plus c. Calc Chat's probably going to write that as a square root, but same thing. All right, let's do some with trig. Now that we got the hang of those, right? After 6 examples, you're now experts in U substitution. Antiderivative, cosine of 4x dx. I want to pick a u so that something like du shows up. Thoughts on what u might be? I'm glad you picked that. Anything but what you said. Yes, earlier I said I wanted somebody to pick the wrong one because it happens. It happens a lot, especially when you're first starting U substitution. Like you don't know yet, and so you try it and see what works. Derivative of cosine is negative sine, and then times 4. Okay, well the 4 I can fix. That's not a big deal. But if I make u be cosine of 4x, there's no way to get a sine of 4x in there. I can't multiply by sine of x and divide by sine of x. I can only do that with numbers. So, not a bad guess, but doesn't work.
So, I don't know if this is just like the example you've done, but is it if you do, like, if you have to do chain rule for du, would that mean you did, like, the substitution wrong?
Not necessarily. That's a good question. If you have to do chain rule like here, does that mean you did the wrong thing? Not necessarily. Did we not do the chain rule in any of the others? I don't think we did. I think you're right. So it's a good observation, but it's not always true. Although it does get to something in that you want to pick u to be something complicated, but not too complicated. And the too complicated thing means you would end up using the chain rule. So you're on the right track with that thought, but it's not a hard and fast rule. All right, how about another guess for what u should be? Andrew, I think you had another choice. Let's go with 4x. And du is just 4 dx, which we can handle the 4. 4 and 1/4. 1/4 integral. Whoops, that's not u. Just this is u. Cosine of u du. Okay, what's the antiderivative of cosine? The underderivative of cosine. This 4 dx is du. Yes, and the integral of cosine is sine. So 1/4 sine of u plus c, 1/4 sine of 4x plus c. That's an easy one to check if you want to check it. The derivative of 1/4 sine of 4x. So the 1/4's out front. Derivative of sine is cosine. And then chain rule, derivative of 4x is 4. And the 4's cancel out, and you get back to what you started with. Again, I don't really expect you to check all of them, certainly. But if you hit one that you're not sure of, it usually doesn't take too long to check and make sure that you did it correctly. Connor, did you have a question?
No. The title of the video.
Okay. integral of sine cubed of x cosine of x dx. This is a good one to guess some wrong things on. Do you have an idea what u could be so that du shows up? I'm glad you said that. U is never going to be x, because then all you do is change your variables and it doesn't help anything. Okay, so I'm glad you made the suggestion. U will never be x, because you'll end up with exactly the same thing with u's in it. So it's not wrong, it just doesn't help anything.
It's just because we used like the little part after the cosine before.
Oh, I see what you mean. Yeah, we used the argument last time. I want to pick some part of the integrand so that the derivative of what I pick is another part of the integrand. Like we picked 4x because 4 showed up. We did not pick cosine because there wasn't a sign to show up. Okay, so here are some options. If we pick sine cubed of x, then du is, and you probably tell by the way I've worded that this isn't it, 3 sine squared of x times cosine of x. Right? Chain rule. So if this is u, then that's not du. That's too much stuff. What did you suggest? If u is cosine of x, then du is negative sine of x. So we've accounted for the cosine. I don't really want to be cubing du. That's not really going to work. So it's kind of there, but it's got that cube on it. It couldn't be that. You have to take the sign of something. I wonder if this would, if I wrote it this way, would help. This is the same thing. There's kind of only one more guess. Sine of x. Because if u is sine of x, what's du? Cosine of x. That's great news because that's what's left over here. So that one was a battle to get the right u, but as with most of these, once you get the right u and du shows up, then the integration is actually not too bad. So that would be u to the 4th over 4. So 1/4 sine of x to the 4th plus c. I'm not going to check that one on paper, but I could check that one in my head. Bring the 4 down, reduce the power to 3, so I've got sine of x cubed, and then chain rule cosine x, and sure enough, that's what we started with. So that was a good one, because the more complicated they are, the more options you have for u, and the more chances there are to kind of mess up what u is. Again, this happens a lot. Even when I see a new one that I haven't seen before, it's like, well, it's a little bit of trial and error until something works.
Why didn't you put sine over 4? Was that just...
Why didn't I put this over 4?
Yeah.
I mean, because the 1/4 out front's the same.
Okay.
So yes, you could have written it like that. A couple different options for both of those 4s and where they go. One more. Death by 1,000 examples today. The integral of tangent squared secant squared dx. So, do you know the trig derivatives well enough to pick one of those so that the derivative shows up? You're nodding your head. What do you think u should be? Why do you say tangent? That is a great answer, and that is correct. You pick u so that du shows up. And sure enough, there's du. Tangent is u, so that it's squared. Connor, your observation earlier is looking more and more accurate, although I'm still not ready to say it's all the time true. But it goes to the fact that you want to pick something that, you want to pick U to be something kind of complicated, but not too complicated. Because if you make it too complicated, then your derivative is going to be a mess and it's not going to show up. But if you don't make it complicated enough, it doesn't help. And so that middle ground there is what you're looking for. Although I don't know that I'd phrase it that way. Pick U so that du shows up. And the more competent you are at knowing your derivatives, the easier that is. U cubed over 3. So tangent cubed x over 3 plus c. Oops. Page 301. Book assignment is, the calendar isn't exactly correct. 7 through 29, every other odd, and then 39 and 41. And that's section 4.5 if you're calc chatting for answers, which you should be calc chatting for answers.